Ziti Kitchen came about from me just casually showing both Clint and Dave some stuff that I've been doing internally, and our team had been doing internally, to kind of make an effort to try and dog food Ziti some more and just find internal use cases for using it. And it was kind of funny because both Clint and Dave said the same thing in the same day, where they're like, "Oh, you should do a kitchen on this," to which I heavy sighed, and after Dave suggested it and insisted, I reluctantly agreed. So this is just kind of learnings and so forth from us, trying to find additional ways to dog food Ziti, in addition to Mattermost that we're already doing as we began to ramp up and scale with our product. Having internal reference networks that were actually using Ziti was immensely helpful to kind of give us example networks to look off of, but it also just gave us a lot of learnings in terms of how to use our product better and some different benefits that it can give us that we maybe hadn't initially thought about. So, for those of you who don't know me, I'm Mike Guthrie. I lead our RAV team, and it stands for Reliability, Automation, Visibility. And I've been doing a mix of software development and DevOps for probably about 10 years now. I like tools that I can get a lot of mileage out of and that solve problems for me. Anything that I can label as a Swiss Army knife type of tool, I tend to adopt into my collection and use it heavily and promote it internally where I'm at. I've been, as I begin to find more uses for Ziti, I would say in the networking space, I'm beginning to classify it as one of those tools as well. Make this go forward. All right, so let's first step into the mind of a DevOps engineer. Little known secret in the DevOps space. You ask any DevOps engineer what they do for a living, they might give you some sort of canned answer, but truthfully, after doing this for 10 years, most DevOps engineers, they can't really describe very well for you what they actually do for a living, because we do such a wide range of stuff. Everywhere you go to work, it's going to be something different. But a couple common themes that you're going to find in DevOps at any company, at any engineer that you talk to, there's going to be a couple common traits. Number one, we love to automate stuff. Anything that's manual, we will try to get away from it. We try to get a system to automate it, and so that we can have problems being solved for us. We generally wire systems together to make them communicate, make them talk, because that facilitates automation. We also create visibility into systems because that's how we know if they're running and they're stable and they're reliable. We don't like manually administrating systems. That's kind of an old school methodology of managing a system. We love to build systems that manage other systems for us. And ultimately that lets us automate more, wire more things together, and build cool stuff. So now, when I say a system managing a system, what do I mean by that? And a couple of you guys have seen stuff like this before, but this is just to kind of give you an example of what I mean by a system managing a system. So this is like a CI/CD example. So you've got, developer pushes code into a repo that triggers an automated build process. You might have automated security scans, checking the code for vulnerabilities, and doing all sorts of analysis. You'll ship off and store your artifact into a storage place for that revision of the code. You'll kick off a series of automated tests based on that. If the automated tests look good and everything's happy, and whatever test volume you do against that change set, you might automatically deploy that code to production or to staging or whatever. And so I just try to grab general concepts that most people repeat most places. And anytime you're doing an automated deployment, you'll have things like database migrations. You might have updates that occur to your database structure that have to correspond to your code changes. That might be part of your automated promotion process. You might have config management that's tied to your code change. For example, you might have AWS resources that need to accompany your code changes. Those might be part of your CI/CD build pipeline. And of course, the actual code deployment itself, the system will deploy and send your code and put it out there into the wild and run it for you. All of this stuff is in a lot of places entirely automated or at least partially automated and so forth. This is, of course, it sounds really great. It's awesome. It lets you do a lot more with a lot less staff because you don't have people manually clicking buttons. The system is managing the system for you and making all the decisions for you, whether or not it's a good build or not, and whether or not it should go live. This is a commonplace in DevOps shops everywhere, and it sounds really awesome. Problem is, This guy thinks this sounds pretty awesome too. And if you've ever watched the show Mr. Robot, it's very entertaining. I encourage you to check it out. It's a story revolves around a hacker. I now, after watching that show, I will always picture Rami Malek as the guy trying to break into our system, because that's the mental image of the guy trying to come after us ever since watching the show. He thinks this kind of system is really awesome too, but for different reasons. Number one, this system most likely has a whole bunch of network access to a lot of things, because it needs to do lots of stuff. It needs to send data in a lot of places, access data in a lot of places. It needs to ship code a lot of places. Therefore, it's got a lot of open doors to it in terms of what it can do. Another thing a system like this has is it has access to lots of credentials in order to talk to the security vulnerability scanning systems, in order to talk to the databases, in order to talk to the cloud providers, the config management systems, whatever. An automation system like this, it has to be able to have credential level access to all of these things as well. Generally, not just service accounts. A lot of times it needs to have pretty elevated access to these systems in order to actually replace what a human would normally do. And so sometimes this level of access is very high in these systems, and sometimes as much as full admin access. Generally, these types of systems have access to data stores, your databases, your logging systems, whatever. Might have access to cloud management systems or config management systems, you name it. And of course, and more importantly, and also has the ability to deploy and execute code in other places. In terms of a target for a bad actor, this type of system, where it's a system managing other systems, is kind of a jackpot in terms of somebody trying to go after that. Hackers know this and they go after this. The reason I wanted to cover this is that most of the really big name tools in DevOps space, whether it's your CI/CD system, whether it's your monitoring system, Kubernetes, Salt, you name it, most of the really big DevOps named tools I would put in this category as basically this is kind of a gold mine of a hacker to go after. And the reason being is that not only do you gain control of this system, but it gives you the doorway to gain control into a whole bunch of other systems throughout the infrastructure. And so being able to secure these systems is a big deal. Now, of course, this sounds terrible, and this would never actually happen in reality, right? If somebody get into your system that manages other systems, except this actually happened a couple of weeks ago to Travis CI. And they put out a public announcement saying, hey, Travis CI repositories, they were injected into PR builds. So pretty much everything that I described in the slide above, this actually happened a couple of weeks ago, just in case you hadn't heard. This is a big deal. And if you're in the DevOps community right now, you're probably searching and thinking of ways to figure out how the heck you're going to secure your CI/CD systems, your monitoring systems, whatever, because more and more you're seeing these types of attacks where people are going for these types of things. And even when I was doing, I worked for an infrastructure monitoring place even 10 years ago, that was one of the first things they taught us in training, is they said, okay, so very first thing is you need to super secure your monitoring server, because hackers know what they are and they know to go after them because they have keys to everything in your infrastructure. So in general, DevOps systems are a high value target. And I had a very smart security friend tell me one time, he said, you know, hackers are going to go after two types of things. Number one, first and foremost, they're lazy. So if something's easy, they're going to go after it just because they can. But he said the other type of system they're going to go after is if it's valuable. The more valuable it is, the more time they're going to spend trying to go after it, because it opens the door to potentially other systems. So in terms of what we wanted to use ZD for in terms of NetFoundry, in terms of securing systems, I'm going to go over a couple of our internal use cases in terms of things that we have either already secured or are in the process of securing. So the first one that we tried to secure was our data warehouse. This is the data warehouse. Even though we remove anything sensitive, we don't store credentials or usernames or anything like that in there. The fact that it has a mix of operational data, business data, you name it, it is a central collection point for, by and large, most of NetFoundry's data. It's an extremely high value target. And when we launched initially, while we're getting everything working, it was The port was open to the world. It was simply a username password combination protecting it. And that's the kind of thing that somebody can brute force that if they want and try and get in. And increasingly over time, that began to keep me up at night. And we needed to figure out a way to lock this down. And so as ZD has matured this year, we decided, well, let's walk through locking it down, and let's put it behind Ziti for all of our user access. And then if we can't Zitify it, we'll lock it down to security group and so forth. Another one, for case in point, the reasons I just showed, we're going to secure our Jenkins server as well. We're going to remove public access for that next. We are in the process of doing that, and I'll kind of show you some of the steps that we go through to actually migrate and put something behind Ziti and take away the public access for it, and how we did that rollout. We've been discussing Bastion SSH for a while in terms of putting that behind Ziti and so forth. We've probably been discussing it for about 2 years. That's next on the radar once we get through Jenkins. And the other benefit of that is auditing SSH access is very cumbersome, very, very painful. And I'm going to show you some reasons why Ziti can help us with that process as well. And then the last one is just in interacting with Ziti and using it for some internal purposes and working with Ziti proxy, I came across some neat tricks that kind of help with local development. And I'll kind of take you through some of the uses that I found for that as well. So. All right, so the data warehouse migration to Ziti. Initially, I was a little bit concerned about it. So typically, I would say historically, when I've worked in any kind of operational space, anytime you go to where it's like, okay, we're going to lock down this resource, that to me is always synonymous with, okay, we're going to break a whole bunch of stuff, because anytime you are cutting off access and you're securing stuff, that means inevitably you've got a whole bunch of stuff talking to this resource that you didn't think about, and you're going to break lots of things in this process. And it's usually painful and a lengthy process while you figure out all these things talking to this resource. So I knew we needed to do it. I didn't want to put it off any longer. And so I said, well, let's figure out how to do it, because we got to get this thing off of public access. And so much to my surprise, the switchover was way easier than I was expecting it to be. And it ended up not being nearly as difficult as I thought. And especially the rollout to the users, that actually ended up being the part that we heavily relied on Ziti for. That ended up being the easiest part of all of this. And so in terms of how did we get from having our data warehouse being publicly accessible to being restricted behind Ziti, very first thing we had to do was just identify, okay, what are the things that we can't put behind Ziti that need to talk to this? And so we narrowed it down to basically our data studio, which is running in Google Cloud, which they are nice enough to expose a list of IPs that are outbound for them, that can be whitelisted. And so we grabbed that bank of IPs, and Randy Hoffman came across AWS has something called a prefix list, which is something that it's a managed list that you can label and put a description on. And then that list can be incorporated into an AWS security group, which makes for just a really nice way to manage a bank of IPs that correspond to a specific thing. And so we created a prefix list for the Data Studio IPs. We also pulled in, we already had, through Terraform, we already had the IP addresses of our MOP services in our various environments. We added those to the security group as well, so that we could at least restrict it to kind of the more public things that would need to access it. At least we were locking it down to those specific IPs. And then, of course, we in terms of the things that need immediate access to the data warehouse, we're doing a router terminated service right now. So we locked it down to the edge router that was in that private VPC, and we also locked it down to the ETL box. And the ETL box is how all the data gets into the data warehouse. In terms of the end user switchover, which was the part that I had assumed might be painful, that actually was incredibly easy. What we decided to do was we kept the host name and the port combination the exact same as what it was in reality. So we kept those the same, and then just did a router terminated service on our tools Bastion. And then what that allowed us to do is that we were actually able to start putting users into that app WAN before we turned off the public access. And so, and my down arrow is not wanting to work. 1 second. There we go. And so in terms of getting users migrated over, it was actually really easy. We were able to validate that everybody was accessing it through Ziti, and we could tell it was working because we simply started watching the traffic come in. And so what it allowed it to do is that anybody who was already using Ziti Desktop Edge, once we put them in that app WAN, the intercept just kicked in to where they maybe didn't even realize that they were accessing the service through Ziti now. But we could actually see it on the metrics dashboard. They're like, oh, yep, they're already good and working. We don't even have to ask them if their connectivity is good. We can see their traffic passing through Ziti now. And that was the way that we were able to monitor the rollout. And once we kind of verified that all of the, particularly the power users of the data warehouse were already behind Ziti, Evan and I, we just did a test and we turned off public access. Again, I was fully waiting for all kinds of explosions, and there really weren't any. And because we'd already migrated everybody and it was already done by the time we turned off public access, and we'd already done all the validation before making the cutover. In terms of locking things down, this was probably the smoothest one I've ever done. And it was kind of a non-event, and I was expecting a lot more fireworks and explosions, and really it ended up not being a big deal at all. And the piece that the fact that we were able to do this traffic validation ahead of time made it so it was not this high risk cutover, because we already knew everybody who needed to access it. They were already accessing it and connecting to it over Ziti ahead of time.
I will say, Mike, the smallest spark it's so low friction that I forgot it was done that way. When I had to bring something else, a new system online, when I replaced a system, and I say this because it's true. I forgot that it was accessed via the data warehouse, and I was very confused as to why my script was failing on the new system. But then I opened up my desktop and it worked. And I had completely forgotten that Evan had sent me an email and said, I configured you for this service, because the way I accessed it from my desktop never changed. So it was, in my case, it was actually so low friction that it caused a problem, which is an odd thing to have happen.
Yep. And taking that idea, I kind of did this as kind of a quiet experiment as we began to prep for securing Jenkins, is that using that idea of, like, if you simply take the existing host name for this service that you want to secure, and you use the same host name and the same port combination, as long as these people are already enrolled, you can move them over without even saying a word about it, and they really actually don't even have any idea. And so as we began to prep for the switchover for Jenkins, which will probably be next week when we turn off the public access, all of these people in this list right here, they're already accessing Jenkins through Ziti, and any concerns about, well, is it going to work reliably or not? Well, these people have been accessing it through Ziti for a couple of weeks now, and I didn't even tell them, because I figured, well, unless it's broken, let's see if anybody complains. Nobody said a word about it, and most of these people on this list are accessing Jenkins every single day. And at doing this method, we're able to kind of monitor the rollout without creating the hard cut situation that is often high risk in a switchover like this, where you do the prep ahead of time, you monitor the traffic as it comes in, and then at some point you just turn off the public access, and by then it's a completely transparent change. Nobody has any idea that you even did it. So in terms of the process for securing Jenkins is exactly the same. Identify your cloud services that need to talk to it. In our case, it's Bitbucket being the key one. Set up the intercept to use the existing host name and port. Watch the traffic come in as you put people in that app WAN. Make sure everybody's enrolled. And then next week we'll do a test. We'll turn off public access. If anything does break, we'll turn it back on and figure out what we need to add to the security group. But yeah, it's a very, very similar process. So in terms of a migration and switchover, this method is pretty fantastic. It just makes it very, very seamless, very, very easy to switch over. And I like easy. It's a lot easier than flames and running around and firefighting all day. So. All right, so I want to talk about another added benefit around this too. So accountability and auditing. Mike Gorman's probably going to laugh at this piece of it. So let's say a character like Mike Gorman comes to you and you're a DevOps engineer and says, hey, there's been a security event. We need to see who has accessed, we'll just say a production database. We'll just say there's been a security event. We need to see who has accessed this something in the last 30 days. You immediately, step one is you immediately bury your face in your hands and accept that whatever you were planning on doing that week is not going to happen now. You're going to now sift through logs to try and be able to answer this question. Step two is you're going to hope and pray that, the whatever logging needed to be enabled, 2 years ago in order to have this thing be monitored appropriately was actually enabled. And, somebody told you in a meeting you should turn it on, and hopefully you don't remember if you turned it on or not. Hopefully you did, and hopefully then you pray that it's somehow still working, because nobody's looked at this stuff in 2 years and it's either working or it's not, and hopefully you have the data. After digging through, you realize, yeah, I did actually check that box that turned on this logging that I need to be able to determine who accessed the system. That your reward for that is now you get to spend some time mining through, terabytes worth of logs to determine who the heck, has accessed this. How do I translate these IPs into actual users and so forth? A lot of existing logging auditing for security access, it's based around IPs. In an increasingly remote world where people are accessing stuff from coffee shops, from their tethered phones, you name it. It's having effective auditing in terms of who accessed this service and when is really, really painful. And unless you've put in a huge amount of work to make this auditing effective, most people's isn't very good. So the ability to answer the question, who has accessed this within this time window, having that data be effective to answer that question is really, really painful. It requires a ton of work and requires a ton of data collection and mining and inferring and correlation and all this stuff to determine who actually accessed this. In a Ziti world, it's really easy, like really easy. So if you set it up as Ziti as your only access method to these things, when Mike Gorman says, hey, I need to know who accessed the production database in the last 7 days, I can just go to the metrics dashboard and I can say, oh, these people. And if he wants a CSV, I'll just give him the CSV and I can go about my day. And the question is done. This kind of visibility in terms of, who has accessed it and when and so forth. It doesn't tell me what they did, but this is a huge step forward in visibility, especially at the network layer. I'm trying to get this type of network level visibility using traditional methods is really, really difficult, really painful, and usually not as good as what we have baked into Ziti. So the access and auditing is a huge, huge win. And just even from a rollout standpoint, as I look at, let's say I need to look at, license seats for a technology. Well, who actually needs license seats? Who's actually using this thing? I can go back and look for the last 30 days and see who's accessed it. Super handy for that purpose as well. All right. Let's see. Yeah, I'll keep plowing ahead and we'll do questions, discussions at the end. So last one is more, it's easier to show it than to explain it. This one's a little bit more of a think outside of the box use case for Ziti. And this is stuff that I came across as being helpful to me as I did local development. Because every once in a while I'll chip in and be dangerous and actually contribute some software somewhere to NetFoundry. So just to give you an example, if you've never had to set up a local development environment at any company, generally this is always a painful process everywhere I've ever been. Because you need to run your code locally, but you have all this stuff that your code needs to talk to. And your options are, hey, I either need to run a copy of this stuff on my local machine, or I need to talk to some sort of a shared resource somewhere else. And either your options are run a bazillion things on your local machine, or you need to blow security wide open in some sort of shared sandbox environment that everybody can talk to. And neither of those are really very good options. So just to give you an example of what is required at a bare minimum for our MOP developers to run the stack. We talk about a microservices environment, which sounds really good, but for a local development environment, it's actually a horrendous thing to try to run on your local box, because this is like a bare minimum setup. Just to run what is needed at the service level on your local box for the MOP, you need what's called API gateway, you need core management, and you need authorization. But beyond those three services, beyond those three Java apps, you also need need a data service, which is another MOP service. They need an identity service. They also need an authorization database. These two services each have their own databases that also need to be running. You need a RabbitMQ server. You need a Redis server. You need certificate service. All of these, there's like 15 things that need to run on a local development environment in order for the mop developers to run the code locally. It's really painful. Usually when a new developer starts, I joke that it's new employee hazing, because we basically be like, hey, we'll see you in a week after you get the local development environment set up. It's brutal in terms of how much stuff they have to get wired up and connected and all talking. And then the other thing that's painful is keeping it all in sync. And I'd come up at, and something that I'd come up with, and I'll demo it shortly here, when I was doing development around ZD metrics processing, is that I needed to do something similar, but I didn't want to have to run all kinds of stuff on my local box. I just wanted to run the code on my local machine and leverage the stuff that we already had running in Sandbox, because it was already there, it was already up to date. I didn't have to worry about it. And so because I was already using the ZD tunnel in proxy mode on my laptop, because for the longest time I had a Mac laptop that was too old to actually run the ZD Desktop Edge. I got very familiar with the ZD proxy, and I started to realize it's actually a really handy tool for local development, because when you run ZD tunnel in proxy mode, you're basically just exposing a port on your local machine. And so if you say, hey, localhost port, 4545, whatever, it will go to whatever the ZD intercept is on that port, and it'll intercept for me. And typically in a local environment, you're always talking to stuff at localhost. So for local development environment, it's actually really handy. So something that I'd come up with, and Jens was my guinea pig for this, but the idea was, let's see if we can run our mop stack with as minimal stuff running on our local box and as much running in Sandbox as we can. So in doing that, everything that you're seeing in this list, we were able to move into Sandbox, and all of these things can run out of Sandbox to where you only need just the code for this service, and this service to run locally in order to actually get the stack to run on your local box. Everything else just gets picked up by the intercepts from ZD tunnel, and it will act as if it's on your local host, but it's not. It's already running in the cloud. Cloud worries about hosting it and keeping it running. You don't have to worry about maintaining it on your local box. There's a few additional config mods added for that, and I documented that here. But let me show you an example on a very simple example what that looks like. So with the ZD metrics processing, I had a similar kind of thing where I really only wanted to talk to Sandbox resources, but I wanted the code to run on my local machine. So, so first I have a Sandbox network that I need to pass some traffic over. So this proxy right here, I'm just going to set up a local proxy to basically just pass some traffic and generate some traffic so that I have metrics to actually process. And then this guy up here, I'm going to fire up another proxy. And what this is going to do is that this is going to dial into a Redis instance that's running in Sandbox. The reason this is really handy is that AWS won't even let you expose Redis publicly. The only way that you can talk to a Redis instance is if you're already inside of the private VPC. And so, so I've set up my proxy to talk to the Sandbox shared Redis cluster. And I'm turning on the verbose mode just so you can kind of see some additional logging and whatever, and you'll see the traffic as it goes by. But what that lets me do is that as I'm working on local development, I'll just say, hey, Redis CLI tool is a way to talk to a Redis server. And by default, it just talks to localhost. So I'm going to do a Redis ping against my quote localhost Redis. And I actually did a ping against the Sandbox Redis instead. Cool, I'm connected to Redis, I can talk to it. Now I can basically treat the Sandbox Redis instance as if it's on my local box for local development. And now I've sped up my local development. So I can just run my local code, and basically I've wired up dependencies that are shared and they're running in the cloud, and I don't have to worry about keeping them running all the time on my local machine. And I've sped up my development, development lifecycle. So, and of course you can see all the traffic, and it's doing heavy interactions with Redis and Sandbox instead of running off my local machine. All right, so those are just some of the practical stuff that that my team and I have done in terms of trying to adopt ZD and figure out ways that we can use it.